Today we're diving into Sam3, Meta's new foundational model for computer vision, and a major leap forward from previous versions. While Sam1 and Sam2 could segment a single object at a time, Sam3 can identify, segment, and track all instances of any concept you describe, simply from a text prompt or an example image. It can operate using two key segmentation paradigms: promptable visual segmentation, PVS, and the new promptable concept segmentation, PCS. PVS is the original task defined by the Segment Anything model series, Sam1 and 2. It focuses on segmenting a single, specific object instance guided by visual or geometric prompts. PCS is the major new capability introduced by Sam3. It transforms the model from a geometric tool into a concept-level vision model by enabling open vocabulary, multi-instance segmentation based on descriptive concepts. Sam3 is able to process images where, for instance, it is able to detect the car closest to the point of view in videos. In this example, for instance, it was able to track a Christmas tree across several frames. Let's now dive deep into the architecture by referencing the original paper. The process begins with two inputs: the visual input, such as an image or a video frame, and the concept prompt. The image is processed through a powerful vision transformer that extracts rich multi-scale features. The prompt can be text, like penguin, an image exemplar such as a bounding box around an object, or visual prompts like points or masks. Each of these gets converted into embeddings that tell the model what to look for. All of this information is fused together in a DETR-based detector. This component combines the image features with the prompt embeddings so the model can understand both the concept and its location. A key innovation here is the presence head, which predicts whether the requested concept actually exists in the image, helping avoid false detections. The detector then outputs bounding boxes, detailed segmentation masks, and a unique ID for each instance of the concept. For video, Sam3 adds a memory-based tracker. Frames pass through the same vision backbone, and the model propagates masklets, temporal segments, across time. A memory bank keeps track of each object's appearance and masks to maintain identity even when objects disappear or reappear. A matching and update stage merges new detections with existing tracks to ensure consistent IDs across the whole video. Sam3 also keeps and expands the interactive refinement tools from previous versions. You can add positive or negative clicks, draw boxes, or provide additional example images. The model immediately adjusts its understanding and refines the segmentation of all similar objects, either in a single image or throughout a video. Sam3 delivers a new level of precision and flexibility in computer vision. Whether you're segmenting many objects in a still image or tracking them across frames, the model adapts to your prompts and produces accurate, high-quality results. It marks a significant step toward more general-purpose vision systems and opens the door to a new generation of AI applications. I'm now going to show you how to install Sam3, and we will run a notebook where we will do prompt concept segmentation on images and videos. Let's see how to install Sam3. First of all, you have to clone the GitHub repo. Then create an env to install Sam3 dependencies. Pyenv virtualenv 3.12 Sam3. Install Sam3. Pip install e. On my side, I'll have to install specific CUDA version in order to let PyTorch to work on my GPU. Optionally, you can install example notebooks. You can also optionally install development and training dependencies. Then have to request Sam3 weights. The access so far need to be requested on Hugging Face Sam3 page. Once it is accepted, you can download the files and put in the same repo of your project. In the notebook, then you will reference the path. Now you can download the notebook from my repo and put within the Sam3 folder. Before starting the notebook, if you're executing everything locally, you'll need a good GPU with a VRAM of 8 to 16 gigabits. Sam3 model is pretty big, and especially when processing videos it may take long time. First of all, we have to import the libraries. Let's define the path to the model weights. You need to point to the .point file. In order to process an image, you have to instantiate the model before and then pass to the processor. You'll have to load an image. You can put here the path to the image you want to process. On my side, I've reduced my image by a factor 4 in order to make the processing faster. It is a nice image of a windmill. Before segmenting, we need to set the image, that is to set the image specifications as height and width. You can pass a prompt of the object you want to be segmented in the image. In this example, we will pass the prompt a windmill. Once done, we can segment the image with the method set_text_prompt. It will return an output dict which contains masks, boxes, scores. We have defined later a series of functions to help results visualization. You can now see how the model have exactly segmented our object. Before showing how to segment a video, we have to free the GPU memory. Let's import all need libraries and write some support functions. We will also downscale our video to speed up the processing. We will segment the plane in the video. Let's have a look to the original video. We can now segment our video. For video segmentation, we need to start a session. As before, we can pass a conceptual prompt and the model will extract it from the first frame and then propagate to the others. This process is extremely slow, and I've executed the notebook before. I've plotted a few frames here in the notebook. We can observe how the model has accurately detected the plane in the video. We can save the video and see the output. You can clearly see how well Sam3 tracks the plane across the sequence. I hope you have enjoyed this video introduction about Sam3. Could be used in particular for conceptual prompt segmentation in images and videos. Do not forget to subscribe to my YouTube channel.